be starting with the chapter rational numbers. Okay.
Okay, sir.
Okay. Okay. So, Priyanka will just be having a revision and then we'll be continuing. So, what we did yesterday's class, we'll be first doing that and then we'll be having so that uska aapka revision, you'll be done with the revision for that and then we'll continue with the further one. Okay.
Okay, sir.
Okay. So, Farhan, whenever we start counting something, that we call as rash. Basically, we start counting something from 1 to, right? Whenever, Farhan, suppose you go to your class and you start counting the number of students in your class. So how will you count? You'll count from 1, then you'll say 2, then you'll say 3, right? Like that, right? 1, 2, 3, and you start counting
sir.
anything. You start from 1, then 2, then 3. Okay. So, bache, this is natural counting. So this set of numbers which starts from 1 and they go to infinity, this is known as natural numbers. What do we call them?
Natural numbers.
Natural numbers. Okay. This you have already learned in the previous classes. Now, Farhan, suppose I add a 0 to it. Okay. In them I add 0 to it in the natural numbers. So now this set of numbers would become a whole number. Okay. What do we call them? Whole numbers,
Whole
right?
numbers.
Okay, great. Now, the next thing is, suppose in this whole number 0, 1, 2, 3 goes on to infinity and -1, -2 till minus infinity. But this set of numbers, this is known as integers. What do we call it?
Integers.
Integers. I hope this is totally clear to you. You know this already, right? From the previous classes?
Yes, sir. Yes, sir.
Okay, great. Now, Farhan, what are rational numbers? Okay, now let's talk about rational numbers. Which are rational numbers are the numbers which can be written in the form of p by q. Basically, have you learned fractions and decimals in the previous classes?
Yes, sir.
Yes. Fractions, what was a fraction? In fraction, there was a numerator like this and a denominator like this, right? There was a numerator and a denominator. Numerator, the one which is written up, and the denominator, which is one which is down. So basically, we call the numerator as p. We call the denominator as q. Okay. We call the numerator as p. We call the denominator as q. Now, rational numbers, they are the numbers that can be written in the form of p by q, basically numerator by denominator. But there is a condition. What condition is that? The condition is that the new denominator, the one written down, should not be equal to 0. Okay.
Okay.
Basically,
Okay, sir.
are you understanding, Farhan?
Yes, sir.
Yes. So the number which is written down, that should not be equal to 0. Okay. Rest, everything can be a rational number. I'll give you an example. Farhan, suppose I have 3 by 4. This is in the form of p by q, right? This is p, this is q.
Yes, sir.
So p by q, so this is 3 by 4. Similarly, 4 by 7. 15, we can write as 15 by 1. 15 we can write as 15 by 1. So this is also a rational number. Minus 231. Okay. We can write this as minus 231 by 1. So this is also a rational number. Got it?
Yes, sir.
Yes. Okay. So now this is like this. But if I talk about 0, 0 we can write as 0 by 1. 0 we can write as 0 by 1. So now this is also a rational number. Is this clear, Farhan? What all are rational
Yes,
numbers?
Sir.
Yes, great.
Yes, sir.
Now what we'll understand is what is not a rational number. Rational number kya nahi hota hai. So anything which has 0 under it. Suppose I have 5 by 0. I have 82 by 0. Since I have 0 in the denominator, this is not a rational number. Very simple. If any number has 0 in the denominator, then that is not a rational number. Rest everything is a rational number. Is this clear?
Yes, sir.
Yes, that's very good. Great. Okay. So now suppose something has 0 in the denominator, then it is not a rational number. Then what do we call it? So हम क्या कहते हैं? So anything which has 0 in the denominator, that is not defined. Okay. That is not defined.
Defined.
Okay. Is this clear totally?
Yes, sir.
Okay, great. Farhan, I want you to note this down. Priyanka, is this totally revised?
Yes, sir.
Okay. Priyanka, I guess you have already noted this down, right? Only Farhan has to note this down.
Yes, sir.
Okay. Farhan, please note this down. You can ask me to scroll once you have written this much.
Sir, could you please scroll? Sir, could you please scroll? Okay, sir. Finish.
Are you done, Farhan?
Yes, sir.
Okay, fine. Now, Farhan and Priyanka, please listen carefully. We'll be starting with the properties now. By the way, Priyanka, did you complete the 3 questions? Rest which were
Yes.
left in the diagnostic? Okay, please send it to the team then. Okay. Please,
Okay,
after
sir.
this class, send it to the team so I can evaluate.
Okay, sir.
Okay. So now
Sir,
we'll be starting with, yes, sorry.
the person who sends links, right?
Yes. The person who sends, just send it to them. They'll forward it to me. Okay.
Okay.
Okay, fine, great. Now moving on to properties of rational numbers. Okay, so now moving on to properties of rational numbers. The first property which we have is the closure property. Okay, now what does closure property say? Okay, so now what does closure property say? If closure property basically says, if I talk about addition in closure property, so it says that if we add a rational number to another rational number, their sum would also be a rational number. Okay, if I have a rational number, suppose I have a rational number that is 3 by 5. Okay, and I add to it another rational number that is 4 by 5. So their sum should also be a rational number. Let's find that out. So 3 by 5 plus 4 by 5 is 3 plus 4 is 7 because the denominator is already same. So like terms they are. So 7 by 5. So yes, this is also a rational number, right? Arman, is 7 by 5 a rational number? Oh, sorry,
Yes.
Farhan.
Yes, sir.
Yes. Priyanka, is this a rational number, 7 by 5?
Yes, sir.
Yes. So I can see that when I'm adding a rational number to another rational number, we are getting a rational number. Okay. So this is the closure property. It says that if you add a rational number to another rational number, you will get a rational number. So is this clear totally?
Yes, sir.
Priyanka?
Yes, sir.
Yes. So basically from here we can write that rational numbers are closed under addition. They are closed under addition. This means that they follow closure property for addition. Is this clear to all both of you?
Yes, sir.
Okay, great. Now talking about subtraction. Second one is subtraction. If I talk about subtraction, so suppose I have a rational number 4 by 5. I subtract from it 3 by 5. So this would give me the answer 1 by 5. So I can see that 4 by 5 is a rational number, 3 by 5 is a rational number, 1 by 5 is also a rational number. So when I am subtracting a rational number from another rational number, I am getting a rational number. Okay. So all three are rational numbers. So basically this also holds true for subtraction. Is this clear?
Yes, sir.
Yes, sir.
Very basic, very basic. Okay. Now this would hold true for every rational number. No matter what you add, what you subtract, any rational number you add or subtract, the answer would be 1 by 5. Is this totally clear to you?
Yes, sir.
Great. So rational numbers, we can say the rational numbers are closed under subtraction. Now moving on to the third one, that is multiplication. Let's talk about that. So suppose I have a rational number, let's say 4 by 5 only. I multiply to it 3 by 5. So the answer would be 12 by 5, and all of the three are rational numbers. Okay. Let's check about 0 also. If I have 4 by 5 and I multiply it with 0, uh, Farhan, is 0 a rational number?
No, sir.
0 is not a rational number. Are you sure? Think about it. Can I write 0 as 0 by 1?
Yes, sir.
Yes, it is a rational number. Okay. You have to keep in mind that 0 is a rational number. Okay. Both of you, this is very important. 0 is a rational number. 0 can be in the numerator, but 0 should not be in the denominator. Okay. Just keep one thing. 0 cannot be down. 0 always has to be up. Okay.
Okay, sir.
Okay, sir.
Okay. So now 4 by 5 into 0 is also equal to 0. So now I can see that this is a rational number. Yes. This is a rational number. 0 is also a rational number. 0 is also a rational number. So I can see that if I multiply a rational number with another rational number, I am getting the result as a rational number only. Got it?
Okay, sir.
Okay. So we can say that rational numbers are closed under multiplication. Basically, they follow the rule for multiplication, closure property. Closed under multiplication. Okay. Now the fourth one is division. So talking about division now. So suppose I have a rational number 4 by 5 dividing 3 by 5. Now this is very important. Listen to it very carefully, both of you, please. First of all, how do we divide rational numbers is 4 by 5. Now what we do is this division sign would change to multiplication, and we will reciprocal the second term. What we will
5 by
do, we
3.
will, yes, reciprocal. So basically reciprocal means denominator becomes the numerator and numerator becomes the denominator. It moves like this. Okay. So now this would be 5 by 3. First tell me, is this step clear to both of you?
Yes, sir.
Yes.
Farhan?
Yes,
Okay,
sir.
great. So now if I cancel out 5 and 5, this would be equal to 4 by 3. And 4 by 3 is a rational number. So this is also a rational number. Rational number dividing a rational number is this. But let's talk about 0 now. What I'll do is, suppose I have a rational number 4 by 5. I divide 0 by it. Okay. Now what will happen is, the next step is, this would be 4 by 5. Now this division sign would change to multiplication,
Into 1 by 0.
and this would be equal to 1 by 0. Now if I multiply this, this would be 4 ones are 4 and 5 zeros are 0. Now tell me, both of you, is 4 by 0 a rational number?
No, sir.
No. So basically, this is a rational number. Yes, this is a rational number, but this is not a rational number. So basically, because of 0, rational numbers do not follow closure property under division. I hope this is totally clear to both of you.
Yes, sir.
Yes. Okay. So from this, we can write that rational numbers are not, I repeat, not closed under division. Okay.
Yes, sir.
Yes, sir.
Okay. Fine. Great. Any questions, Farhan and Priyanka?
No, sir.
No, sir.
Okay. Okay. Great. I want you to note this down.
Sir, could you please scroll?
Priyanka, are you done writing this?
Yes, sir.
Okay, okay. I'll only scroll when both of you are done. So take your time, no issues.
Sir, could you scroll down, please? Done, sir.
Okay, fine, great. So now moving on to the second property, that is commutative property. Second property is the commutative property. Now, what is commutative property? Commutative property is if we interchange the numbers, such as see, if I talk about addition, so in commutative property, which addition means that a plus b should be equal to b plus a. Okay, this means that suppose I have a rational number 4 by 5 plus 3 by 5. Okay, the answer should be for this should be 4 plus 3 is 7 by 5. Okay, now if I reverse it, this should be 3 by 5 plus 4 by 5. Now I'll keep the 3 by 5 first, so this will be 3 plus 4, that is 7 by 5. So I can see that we are getting the same answer in both of them, right? So whether I write this first or that first, it is the same. So this is what commutative property says. So in addition, they are commutative. Is this clear?
Yes, sir.
Yes, sir.
Okay. So we can say that rational numbers are commutative under addition. Now moving on to subtraction. Okay, so suppose I have number 4 by 5 minus 3 by 5. So this would be equal to 4 minus 3 is 1, so 1 by 5. Okay, now if I interchange the numbers, I write 3 by 5 first. 3 by 5 minus 4 by 5. So this would be equal to 3 minus 4 is minus 1. Okay, so this would be minus 1 by 5. Tell me, is the answer same in both the cases or different?
Different, sir.
Different, sir.
Different, right? Because one has minus, one has plus. So since there are different answers, so this means that a minus b is not equal to b minus s. Therefore, rational numbers are not commutative under subtraction. Is this clear?
Yes, sir.
Yes. I want you to note this down first, then I'll talk about multiplication and division. Please write this down. Yes, Priyanka, please note this down. Priyanka, can you hear me?
Yes, sir.
Please note this down.
Okay, sir.
Sir, could you scroll?
Let Priyanka write this down first, then I'll scroll down.
Okay, sir.
Done, sir.
Okay, now note this down.
Done, sir.
Finished, sir.
Okay. Now talking about multiplication. In this case, multiplication is just like addition. So if I have 4 by 5 into 3 by 5, so this would be equal to 12 by 5. 12 by 25, I mean. Okay. Now, if I change it to, what do you say? So, it will be 12 by 25. Sorry. Here also, please change it to, yes, 25. Now, if I exchange the numbers, I write 3 by 5 first into 4 by 5. This will be equal to 12 by 25 again. So we are getting the same answers in both the cases. So they are commutative under multiplication. Easy, got it?
Yes, sir.
Yes, sir.
Actually, these properties are very easy.
Yes, sir.
Okay. Now they are commutative under multiplication. If I talk about division, the same just like subtraction. Suppose I have in division 4 by 5 divided by 3 by 5. So this would be equal to 4 by 5 into 5 by 3.
Into 5 by 3.
So 5 and 5 will get cancelled, we'll get the answer 4 by 3. Now suppose I exchange the numbers 3 by 5 divided by 4 by 5. This would be given as 3 by 5 into 5 by 4. 5 and 5 would be cancelled. This would be equal to 3 by 4. Okay. Now we are getting the different answers in both the cases. So therefore, they are not commutative under division. Rational numbers. This is clear to you?
Yes, sir.
Priyanka?
Yes, sir.
Under division. Okay. Under division. Note this down also. Then we'll continue with associative property.
Done, sir.
Sir, could you scroll? Sir, finish.
Okay, let Priyanka write, then we'll continue.
Done, sir.
So the next property we have is associative property. Associative property. So if I talk about addition in associative properties, what is associative property first of all? Let's see that. So suppose I have numbers 2 by 5 plus 3 by 5 plus 4 by 5, and 3 by 5 and 4 by 5 are in brackets. Okay. So I hope you both know the BODMAS rule. BODMAS rule says that BODMAS is bracket, order, division, multiplication, addition, subtraction. So you have to do the operations in this sense. First you will solve the bracket, then you will solve division part, then you will solve multiplication part, then addition, and the last subtraction. Okay. Now first you have to solve the brackets. So this would mean that 2 by 5, solving the bracket would be plus 3 by 5 plus 4 by 5 is 7 by 5. Okay. Now 2 plus 7 is 9. So this is 9 by 5. Okay. So is this clear? How do we solve it?
Yes, sir.
Priyanka?
Yes, sir.
Okay. Now if I change the brackets, now 2 by 5 plus 3 by 5 are in a bracket, plus 4 by 5 is outside. So 2 plus 3 is 5 by 5. So this is 5 by 5, bracket solved, plus 4 by 5. So 5 plus 4 is 9. So this is 9 by 5. Okay, is this clear? So we are getting the same answer in both of them. So this means they follow this rule. So they are associative under addition. Is this clear?
Yes, sir.
Okay. Rational numbers are associative. Yeah, are associative under addition. Okay. Now, if I talk about subtraction, taking the same example, 2 by 5 minus 3 by 5 minus 4 by 5. So this is 2 by 5. First solving the bracket. So 3 minus 4 is minus 1. So minus of minus 1 by 5. Now minus minus is plus. So this would be 2 by 5 plus 1 by 5. So this is equal to 3 by 5. Okay. Now changing the bracket. So 2 by 5 minus 3 by 5 in a bracket, and outside we have minus 4 by 5. Solving the bracket first. So 2 minus 3 is minus 1. So this is minus 1 by 5. And outside is minus 4 by 5. So minus 1 minus 4 is minus 5 by 5. That is equal to minus 1. So we are getting different answers in both of them, right? So are they associative under subtraction?
No, sir.
Priyanka?
No, sir.
Okay.
Sir, I
Are not associative. Easy and boring. Are not associative under subtraction. Okay. I want you to note this down. No issues, Priyanka. I understand you have network issues, so you can write in chat as well. No issues. It's okay, bache.
Done, sir.
Sir, done.
Okay, now note this down. Subtraction.
Done, sir.
Done, sir.